Hey, I cannot remember. Yeah, the standard length of your bars, I think it's 15 feet. Standard length of your bars, reinforcement bars, 15 feet. That means if I have a beam with 20 feet length, how can I put my bars? So I will put the first one 15 feet. What do you think about the second one? Do you think it will be something like this?
No.
No. You have to do splice. This length between this bar and this bar called splice length. So the lab splice length is the length that two rebar must overlap and be tied together to create a bond, and if there was no break at this location. You can assume this bar is one bar from here to here. So you need to add splice. One more thing, remember, development length is amount of length needed to be embedded in concrete. But splice is the overlap between rebar and rebar. So for a simple definition, development length is rebar embedded in concrete. But for a splice length is rebar by another rebar. So sometimes you're splice in a beam like this, sometimes you're splice in column. We have a vertical bars, so we need to do splice like this. To get your splice length, it's very easy. Just a table based on what is the size of your bar, what is the F yield for your steel, what is the FC prime of your concrete. I can tell you how much splice length. So if you are connecting two bars, each one is number 8 with 2500 FC prime, your splice length will be 102 inch splice. So based on this table, I can tell you what is the splice length. Any question? For this one, crushing failure in your beam, if you go back to your design, we have steel reinforcement here, neutral axis. So we have compression at this location, we have tension at this location. We have issue with compression concrete, with compression bar. So your failure will happen at this location. So we have crushing of concrete at this location. Maybe this crushing will extend down, but the first initiation will be at the top, crushing of concrete at this location. Then will be extended to the bottom. Okay? So we'll have a rest this week to prepare for the steel exam. No homework in concrete, no homework in steel. Any question? Okay, thank you.